Okay, so this first example, I didn't have the right thing to type the ray correctly, so some of the rays are typed funny. I apologize. So that just means ray OS, bisects angle ROT, ROT. Find x and the measure of angle ROT. So the angle ROT is really this whole entire space from there to there, so it's the sum of the two parts, right? So that's the measure of angle ROT, and then x is just the variable. What do we know if this ray is bisecting a big angle? What does that tell us, Tristan? Right, the measures are equal. So immediately, if I wrote out angle ROS equals angle SOT, then we substitute in 6x squared equals 5x squared, or I'm sorry, 5x plus 21. Immediately, you got to know, what kind of equation is this? It's a quadratic. When we solve quadratics, we try to get it equal to 0. So I subtract stuff over. So we have 6x squared, this pen's not good, 6x squared minus 5x minus 21 is 0. What do we do next? What do we do next? You have options. Try to do what, maybe? Try to factor. So I'm going to factor using the AC method. Okay? A, C. A is 6, B is negative 5, C is negative 21. AC method, I multiply A and C. That's 6 times 21. 6 is really 2 times 3. 21 is really 3 times 7. I don't have to do 6 and 21. I could break it down and do a different way. So maybe I do 7 times 9 times 2. 7 times 9 is 63. 63 times 2 is 126. If you did 6 times 21, same thing. I'm just showing you options. So we just said that was 126. So 1 and 126. I'm writing down a list of factors. 2 and, here's 2, 63. Because I have the breakdown up here, it's going to be fast to find my factors. 3 and, here's 3. 21 times 2, 42. 4, no. 5, no. 6. 6 and 21, that's the original. 7 and 9 times 2 is 18. Okay? 8, no, I can't make 8. 9 is right here. 9 and 14. 9 and 14. Can I make it 10? No. 11, 12, 13? No. Now I'm at 14, so I'm done with my list. B for but what? But it has to equal the B value of negative 5 when I add or subtract my two numbers. The two numbers I'll use are, winners, 9 and 14. I need a negative 5. What signs will the 9 and 14 be? Negative 14 and positive 9. These two numbers are used to split up my middle term. The first term stays 6x squared plus 9x minus 14x minus 21. I also shared a video going over factoring fundamentals because some of you are struggling with factoring. Some of you crush factoring. So it's 50-50 divide. People who need help with factoring, I posted a video and I recorded it when I was giving extra help after school to someone. So I made a video of it and I shared it so everyone can get the help. I'm underlining the first pair and the second pair. GCF, 3x, GCF, negative 7. The GCF is always going to match this sign. If that's a plus, you got to write plus. If this is minus, you got to write minus. You bring your greatest common factor out front. You bring your greatest common factor out front. Parentheses, parentheses, here's still the equal 0. Don't lose your equal sign in the middle of a problem. Then call it a pretzel, 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 and we reduce each oval. 6x squared over 3x. I'm left with 2x. This becomes plus 3. That one is also 2x. That's also plus 3. 2x plus 3 matches both factors, both sets, right? If it matches, we're winning, okay? If it matches, we're winning. That is my new greatest common factor. What can I do with that? Not yet. This whole thing has a 2x plus 3. This whole thing has a 2x plus 3. It's my GCF. What do I do with it, Ella? Factor it out. Yeah, we bring that out front. Now, if I pull this out, I pull it out front. There it is. What's left inside? Good. 3x minus 7. Boom. That's how you factor. If that's news to you, you got to watch this again later and try it over, okay? Because some of you, it's not clicking, okay? 2x plus 3, we set each one equal to 0. 3x minus 7, set that equal to 0, and we get two answers. Subtract 3. Don't try to be a hero and not show your work. A lot of you guys mess up your positives and negatives, okay? I'll brighten this up a little bit. Sorry. That gives me x equals, I don't know how I did that. X is already written. Negative 3 over 2 is one of them so far. And the other one over here, I'll get 3x is 7. And the other one I get really x equals 7 over 3. So I do get two answers. If you fill them both in, we want to make sure that they match and give us the same angles, like at least they work. You can't get a negative angle, so you would know something didn't work. Did I mess anything up? What's up, Ellie?
I don't know if this is correct, but I did, instead of 9 minus 14.
Negative 14 plus 9?
Yeah, I did
it's fine.
14 minus.
No, because that'll give you a positive 5.
Oh.
So that's the only thing. You could turn it around and make it negative 14 plus 9, but watch the signs. It has to make a number in the middle, okay? All right, so I get those two numbers. We test them in. and we see what we get. If I square them, fill it in, make sure it works, you could get the angle of one, add them together. Do I have to finish the whole problem? Or could I go to the next one? Going once, going twice? Finish it. So if you take x and fill it in, okay? I'm taking 1. I'm trying this one first, all right? So I'm going to try the negative 3 over 2. I'm going to circle it right here. If I fill that in and test it out, 6 times negative 3 over 2 squared. How do you square a fraction? Just square each number. What's negative 3 squared? 9. What's 2 squared? 4. The 6 is really over 1. 6 and 4 I could reduce. Think smarter, not harder. 6 and 4, I reduce each by 2. That's a 3. That's a 2. 9 times 3 is 27 over 2. You don't even have to make it a decimal. It's fine. It's 13.5 if you were wondering. I'm not even going to bother. Now, I'm going to fill it in here, make sure it matches, make sure I don't get negatives, and we're good. So 5, negative 3 over 2, plus 21. 5 is really over 1. When we're multiplying, negative 15 over 2 is this. 21 is really how much over 2? I need a common denominator. 42. Multiply by 2 on top and bottom. Negative 15 plus 42. It's the same as 42, take away 15. 42 take away 10 would be 32. Take away 5 more, 27. Looks good. 27 over 2, they match. Now, if that's 27 over 2, and that's 27 over 2, when you would put something over 2, how much of that number are you finding? Half of it. So if I have half of 27 in this angle, and half of 27 in this angle, how much is in the whole entire angle? 27. So measure of angle ROT, 27 degrees.
Wait, so it's not 7 over 3 because...
If not, say again?
7 over 3 is max.
7, I just didn't check that one yet. So far I have this one. I'm going to check this one and make sure. So I'm going to do that now. It doesn't mean it's not an answer. I might get the same answer. We're going to find out. So I'm about to plug that one in. So I just want to switch colors so I can kind of differentiate a bit. All right, so over here, I'm going to try this answer. Is that too bright? I don't know. No, it's okay. Bless you. So I'm going to take 7/3. I'm going to test that one now. So I'll do it up here. 6 times 7 over 3 squared. 7 squared is 49. 3 squared is 9. 6 is over 1. 6 and 9 reduce. How much do they reduce by? 3. Reduced by 3, this becomes a 2, and this becomes a 3. 2 times 49. 98 over 3. So now this is 98 over 3. Right? Tell me if I messed up anything. Then 5x, so that's 5 times, what was it, 7/3? 5 times 7/3 plus 21. I'm going to immediately put it over 3. 21 is how much over 3? I heard it, 63. 5 times 7 is 35. So I have 35 over 3 plus 63 over 3. 60 and 30 is 90. 5 and 3 is 8. So I get the same answer. So 98 over 3 for both of them. If I add them, what's 98 over 3 plus 98 over 3? 196 over 3. That might reduce. I'm going to do a little long division. I'm sorry, it's a little squashed here in the darkness. So 196 by 3. 3 goes into 19 6 times because 18. 1 6. No, it doesn't go even. So it doesn't reduce. So basically, in a nutshell, when x equals negative 3 over 2, ROT is 27. So those go together. When x is 7 over 3, when x is 7 over 3, then measure of angle ROT is 196?
So they're both right?
Yeah.
So we don't say which one's which.
I mean, keep it in order.
That's like such
First number, first, second number goes with first number, second number.
So we have to test them.
They're both, they're probably both going to work, but you would fill them both in. But I'll be clear on any direction. I'll tell you. Make sure you check both answers or something.
And you can use negatives.
Yeah, x is negative, not the angle. If I got an angle, like negative 27 degrees for an angle, then that's questionable. It doesn't matter that x is negative, it's just what we're filling in to get our angle measure. We just have to get positive angles right now.
And do we have to where the answer x equals, we have to write each one?
Well, yeah, you could write x equals this, x equals that. You could put a comma or put an and symbol. Don't put a plus. That's not and. You guys keep writing plus signs, because then that means the answer is the numbers added together. So you just want to watch out for that, okay? So we have a couple more examples here. Do we want to try this one? Okay, so now here we have a proof of some angle stuff over here. Now you guys still have your little workbooks that have definitions in them. We also have our the packet I made for you guys with all the postulates and theorems, right? So we can access those and look at those right now, but you probably know the answer without really having to think too hard. Your instincts are probably correct, okay? So you gotta trust your gut for a lot of these and just go for it because it's probably right. So do you guys want to take a minute and try this one for a second in pencil? I'll hit pause and then we'll come back and do it together. So I'm just going to pause. All right, so all I wrote down for us so far is the given. I just wrote angle AOB is congruent to angle GHF, and then angle BOC is congruent to angle FHE, and obviously that is given. Then Ellie even just asked the question, so I kind of just tied that right in right away. So step 2, I just took exactly the last given statement, and I just swapped out equal signs. And I just wrote segments. What did I mean to write? Silly me. Angles. Silly. I had segments on the brain. Okay, so that should say angles, sorry. All right, definition of congruent angles. All right. Now, from here, think about what we want to prove. Think about what we already have, okay? I already have angle AOB, which is this guy right over here, is congruent to GHF, which is this one right over here. Then we also have angle GHF, so looking here, BOC, sorry, BOC, I don't know why I changed the color for that one this time. Oh my gosh. BOC is congruent to FHE, right? So BOC is this one, marking that twice in the purple color, and FHE twice in the purple color. That's what we were given. Now, what are we trying to prove? We are trying to prove angle AOC, this whole entire angle is equal or congruent to GHE right over there. Okay? So I have the given. I just changed it to equal sign so I can add, subtract, and all that. It's a little hard to read the light blue. I won't use that anymore. Okay, number 3. What can I do in the next step? I kind of got it started. Go ahead, Maren. AOB plus BOC. AOC, sure. And what else can I add? GHF, FHE equals GHE, the sums of the two adjacent angles equals the whole entire angle for both cases. And what allows me to do that? Who could tell us what that's called? Go ahead, Delilah. Sure, angle addition postulate, okay? Angle addition postulate. Next step. What can I say next? Something about some other angles being equal. Ella.
Angle BOC plus angle AOB equals.
So the sum of these two, so the AOB and the BOC, good.
Equals angle GHF plus angle FHE.
She's right. Why is she allowed to say that the sum of these is equal to the sum of these? Why is Ella allowed to say that? Thaddeus? Yeah, AOC equals this. And AOC was, where is she substituting? You said AOB. Well, we know that that and that are equal. Oh, because they're equivalent. So that piece and that piece, that piece and that piece. Okay, so she's using substitution. Sorry, I was looking at it like inside out. Substitution, you're good. And then last step, essentially. I think we could do really one more. It's another layer of subbing in. What do we want to prove? So we had AOB and BOC are equal. AOB equals GHF. So if these are equal, and if these are equal, that's why the sum is equal. But we're trying to prove this. So what else can I put? Tristan?
Well, since AOB plus BOC is equal to AOC, can't we sub in AOC?
Yep.
And then since FHE plus GHF is equal to GHE, can't you sub it to that?
Yep. So again, we have another substitution property of equality. Okay. So just kind of have it written out a little bit more here, but same idea. Okay. So you're substituting and substituting. It's just layers of substitution filling in, and it's pretty straightforward. So as long as you're logical, as long as you show that you make sense, you're good to go. And just use the right 3 letters to represent an angle. Use the angle symbol, and we're good. Okay, so this one says OC, ray OC, this one right here, okay? Ray OC bisects angle BOD. So what can I conclude from that information? We're not asked to do a proof, we're just doing some solving. What can I conclude from that information over there? Can you tell me, Caitlin, maybe?
That the angle BOC is equal to angle C.
Good, those two angles are going to be equal to each other. So if that's labeled 2x squared, well, then that's labeled 2x squared. Filling what we know, right? This bisects, so it splits these up evenly. Now, we also said, Elia, what did we say about these 3 angles? What does it look like? You called these 2 things something? Opposite rays. So if we have a bunch of angles resting up against 2 opposite rays, how much do they add up to? 180. So I'm going to write that out. 126 minus 15x plus 2x squared plus 2x squared has to equal, exactly, 180. Now, we'll just clean it up a little. 2x squared and 2x squared gives me 4x squared. I have minus 15x can go right next to it. If I subtract 180 from 126, 120 to 180 is 60 away. 130 to 180 is 50 away. How far is 126 to 180? 54. So if I bring that over, it's negative 54 is 0. Okay, I have a quadratic trinomial right now. So I'm going to find all possible values of x. Questions tend to word things that way more often than not when there's more than one. And then it says check your work. So look for things like that. I'm going to leave this one set up right now, but you're going to have to factor it or use quadratic formula. If it's quadratic formula, you have a calculator to check your work. If it's not, then you could check by hand, okay? You're not going to have a million examples with quadratics that you'd have to check. I would probably have one question that deals with factoring and one question deals with quadratic formula. I'm not going to make you do things 100 times, okay? Ellie, question? if I decide, only if I would make it a quadratic formula one that you had to check. Okay, so I'll decide that when questions are finalized because I'm shortening it because the periods are short tomorrow. All right, because we have a half day straight 8. So just make sure you're going to do 4 times 54 on the side. You'll get a number. You'll make your list of factors. Okay, so that's what, 216. So 1 and 2, 16, and so on. And then that's AC. B equals, I'll finish this later, but that's just sort of set up for us so we could start them all, okay? If you were checking them, you want to make sure that the 3 angles add up to how much? 180, okay? So that should make sense over there. Pausing. All right, this next example, we have KI bisects. Since KI bisects the big angle, that means that this angle is congruent or equal to that angle. What other marking do we have on this picture that's going to help us out? What other marking? What other marking do we have on this picture that's going to help us?
We have 90 degrees.
Right, we have a 90 degree. So not only are these 2 angles equal, but they also combine to add to give us 90 degrees. So how many unknown values do I have? 2. How many equations could I write? 2. My first equation is going to be based on their equality. What can I write down? Because they're equal, Vic. What can I write down?
45.
Well, because they're equal to each other, not because of the...
4x minus y equals 3x plus 2y.
Right, 4x minus y equals, that's not a good color to use, is it? 4x minus y equals 3x plus 2y, you said? Correct? Okay, then what is the other equation I could write based on the fact that they are 90 degrees? And can you tell me another word for angles that add to 90, Elia?
Complementary.
Good, they're complementary angles.
You said x plus 1 equals 90.
Well, they're not x and y, you have to use what they are. So this is this angle, and that's this angle.
So 3x plus 2y.
3x plus 2y
Plus 4x minus y equals 90.
plus 4x minus y, good, is 90. Perfect. So now I have 2 equations. Here's one equation. What kind of equation is that? If x and y are to the first power. Starts with an L. Linear. So I have 2 linear equations. I'm going to clean them up a little. When you have 2 linears, the next thing we do is we solve a system of equations. Good. So I'm going to clean it up a little bit. I'll add this y over, so I have 3y. I'll subtract 3x, so I have x. That's pretty nice because I already know then what x equals. Did I mess up? No, I'm good, right? And then here, 3x and 4x, I get 7x. 2y minus y, I get y is 90. So it's the same equations. I just cleaned them up a little bit. Now, keep solving my system. What method would be pretty nifty to use right now, Pinnell?
Substitution.
Yeah, I'm going to sub this in for that, right? So I will get, let's see, 7x, but x is really going to be replaced with what? 3y, good. Plus y equals 90, dot, 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 and we solve from there. I think you guys could finish that. Go ahead.
You also do it where you step like 3x plus 2y equals 45 and then 4x minus y.
Yeah, you're just writing more equations.
Like elimination.
Yeah, that could work too. You should get the same answers. There's more than one way for a lot of these things. Yeah, when you have certain information, you have a lot of flexibility. So yeah, you should all be good either way. So you just keep going from here, 21y plus y, you're gonna get a fraction for y, plug it in, you'll get x. Okay, so I'll leave it set up there for now, finish it later. Okay. Here, just to jump to another angle proof, we have given information I'm gonna mark up in the picture. Angle AOB, which is that angle right there, equals angle DOC. DOC is that angle right there. That's not showing up at all. All right, there and there. Sorry, I thought the highlighter would be better. Okay, those are equivalent to each other. And we want to prove that angle AOC, AOC is this angle there, is congruent to angle DOB, which is that angle there. This reminds me of the segment question that we did a couple times. And I actually think that that segment question is sort of like this one. AB equals DC, AB equals DC, and prove AC equals DB. Do you see the similarity in them? Okay, so if you know how to do this style, this is very, 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 very similar. They're buds, okay? So you're gonna have your given, obviously, right? First and foremost. So number 1, I'm just gonna save the time of writing it, but that's your given. Now, what else can I write down? An important step that we tend to forget has to do with, like, think of a mirror. What you see inside of a mirror is your reflection. So I wanna talk about reflexive property. So I'm gonna say angle BO, say it, I hear it. C equals angle BOC. So I'm cloning it so I can use it twice. Until you clone it, you can't use it 2 times. That's reflexive property. Now I can use that angle, sorry that's a little sloppy, I can use that angle in 2 places at once, all right? So the given's up there. So number 3, I have that those are already equal. What else can I write down? It's gonna have to be broken down a little bit more. What else can I write down? Take a look at it. Think how we did the segment one. I have this is equal to this. Then I also have that this middle guy is equal to itself. So Elia, what can we write down?
Angle AOB is congruent to angle DOC.
We have that already. That was given. We have that. What else can I write, Griffin?
Angle BOC is between angle AOB and COD.
We don't need to say they're between. I need to think about where I want to go. I want AOC. If I want AOC, then I know stuff about this and I know stuff about this. What else can I do, Isaiah?
You can add together AOB.
Angle AOB plus angle BOC equals angle AOC. And while I'm at it, angle BOC plus angle COD will equal angle BOD. Good. Or DOB, whatever way you spell it, right? That is, why am I allowed to do that? Yeah, angle addition postulate. Even if you feel like you're making up a postulate, you're probably correct. Why? Because mathematicians are really boring and they call the most basic names to things. So angle addition postulate. Okay, so this equals that. This equals that. All right, what else can I do? I already know that equals that. That's this piece here. This was given, right? I know angle AOB equals angle DOC. Angle AOB equals angle DOC. It's just written backwards, right? I also already know angle BOC equals angle BOC. That's this over here. So pink plus green equals pink plus green. What can I write down next? Pink plus green equals pink plus green. Jonah?
AOB plus BOC.
You could skip that step that you're thinking in your head. Equals itself? Yeah, and then what would come next? Look up here. This, and this is equal to itself, right? If A equals B, but B equals C, that means A equals, what property is that? Good, transitive property of equality, okay? So number 4, you could call it either, there's options for this. You could call it the transitive property of equality. You could also call it what else? Yeah, people call it substitution. It depends on your, which way you look at it. I love transitive property. I told you guys it's my favorite, but you totally could call it substitution there as well. So I will work out more of these. I'm going to give you, based on what we did, you're going to have a shortened assessment tomorrow based on what we did, and I will also put more examples online with this video, or actually I'll make a separate video so I can post this one now, okay? So